So last week we looked at the production, firm's production. This week we will turn to the other side of the same coin, that is the cost. So we will construct a cost function graphically, and then use this cost function to decide for the decision making of how many units the output should the firm produce in order to maximize the profit. And we will also use these cost functions for the purpose of break-even analysis. Okay. So we are going to start with two markets. One is the product market, so which is we call it perfectly competitive. Then the firms can sell as many as they want at the market price, maybe P. And inputs market, which includes both capital and labor market, which is also perfectly competitive. Then the firms can purchase inputs in the inputs market at the market price as many as they want. So for the capital market, the price or the rental rate we will normalize the price of capital to be 1, for example, by choosing appropriate numerator. And in the labor market, wage rate is W. Okay. So you might want to ask, why am I normalizing the rental rate to be 1? Here's something I need or make it easier for me to construct the cost functions. For example, we have isocost function, which is RK plus WL, and the associate graph look like this. Straight line where the vertical, I'm putting capital on the vertical axis, labor on the horizontal. So the vertical intercept is TC, total cost, divided by R. The horizontal axis is total cost divided by W. Since I'm normalizing R to be 1, so this is equal to total cost. So the total cost of the production associated with producing a certain labor output can be read directly from the vertical intercept of the isocosts. That's why I'm normalizing the rental rate to be 1. Okay. Let's keep going. So we are gonna have we're gonna use the isoquant, the isocost that we derived last week. And now I'm going to look at long run first, which means both capital and labor, they are freely adjustable. Okay, the vertical axis is the cost or capital. Okay, sorry, let me just capital. Horizontal is labor, and I'm gonna put this axis here, quantity here. So on the capital level spaces, we have isoquant. So I'm going to start with an isoquant corresponding to 1 unit output. 1, 2, 3. And there's another which corresponding to 2 units output. Third one corresponding to 3 units output. Okay, so suppose I want to produce 1 unit output. Then I need to choose a bundle of capital level such that I can produce 1 unit output, which means this bundle got to be on the first, got to be on the isoquant that represent the 1 unit output. So the best or the smallest, the cheapest bundle would be the tangent point of isoquant and isocost. So at this point, okay, that means using this many capital, this many labor. Okay, this many labor, this many capital. So what's the total cost of this bundle? So we can remember I normalized the rental rate to be 1. So the total cost associated with this bundle, let's call this A. It's just the vertical intercept here. Okay, so now I got to produce 1 unit output. The associated total cost of the production is this. Go from 1 up to get this point. And I'm gonna still label this point as A, okay? But be aware that, okay, the point A here means capital labor, and point A on the left hand side is on the dollar, the cost and quantity, okay? Now, if I decide to produce 2 units output, so now I need the high cost to find the associated costs. Okay, I'm going to parallel shift this isocost curve out so that it is tangent with Q, the 2 unit isoquant. So parallelly shift out. Okay, that's B, point B. Okay, so now in order to produce 2 unit output, the best I can do is choosing point B. That's the cheapest bundles. So total cost associated with this bundle B would be just the vertical intercept due to our normalization of the rental price to be 1. So I'm going to go from quantity 2 unit up and get the intercept here. So that's point B. Point B. Okay, now let's keep going on. Let's keep going. So now I want to, suppose I want to produce 3 units. So that means I got to keep shifting this isocost out such that it will be tangent with Q equal to 3 isoquant. So let's bundle C, and the total cost is the vertical axis, vertical intercept. Okay, so I can get a point C, go from quantity up, that's point C. Okay, keep repeating this exercise many times. So we got all these points. So we can link, in the end, we can link this point together. we can link this point together. That's actually what we call cost function. Okay, so in order to make it look better, okay, I'm gonna just withdraw it. So that's dollar. That's quantity here. So I'm gonna flip this part over, so we get something like this. So that's the cost function. The cost as a function of quantity. Okay, that's the long run cost function actually, and it starts from 0, because in the long run, if you produce nothing, like you can adjust both capital and labor freely. So the cost for you is actually 0. So several observations here. One, in the long run, if you produce 0 unit, the cost is just 0. So starting from the origin. Second observation you want to have here is that I hope you already noticed in the construction of this long run cost function, firms actually are optimizing. Okay, so firms are optimizing. So given that the firms actually minimizing cost, to be more specific, given that I want to produce 2 unit output, I need to do it in the best way. I need to choose the bundle that's cheapest. Okay, minimize the cost. Okay. So that's the long run cost function. What about short run? So let's look at short run now. I'm gonna do similar construction. Okay, let's say in the short, if I want to produce 1 unit, then it's bundle A. Okay, that means this many capital, this many labor, and total cost is this many, because of the rental rates is normalized to be 1. So for A, I go from 1 up to the vertical intercepts. I read the total cost, associated cost. Now let's assume that the capital is fixed at one unit. So I'm going to call this 1. Okay, and now I still want to, in the short run, the capital is fixed at 1 unit. So I still want to produce 2 unit output. Now the best I can do is choosing this point, right? So I'm going to shift this iso cost out such that it's this. So that's point B. And now you want to compare, because in the short run is capital is fixed. So compare this situation with the long run situation. Clearly, in the long run, you should do better by, because you are able to adjust capital. So that the total cost in the long run will be smaller. To see this, we can actually shift. Let me choose a different color. We can actually shift this isocost curve to be tangent with this 2-unit isoquant. Okay, parallelly. And we can clearly see that in the long run, the total cost of producing 2 units, this many. In contrast, in the short run is this many. Okay, so in the short run, the cost of producing 2 units output is higher because capital is fixed at 1 unit level, and the firms do not have a degree of freedom to adjust the capital. Okay, let me erase this. So to produce 2 units, the associated cost is point B here. Similarly, for 3 units, so it's this point, that's point C. If I want to produce 3 units, the associated cost I need to pay is this many. So let's see. Now, similarly, repeat this exercise many times. We get this point, link this point together. We get the short run cost function. Let's link them together. Oops, not very smooth. Okay. So let's flip it over so it looks better. Oops, sorry, I need to take one step back. Okay. My mistake, a little mistake. I made small mistakes previously, so let me take one step backward. Let me just get this. So now, in the short run, even if you produce no output, zero output, you still need to pay for the capital, 1 unit capital, and so the associate cost is this many. Okay, because you're kind of stuck with this 1 unit capital. So we actually should link all this point together. Okay, so that's the short one. Okay, and then let's flip this diagram over, so it's something like this. Short run. All right, so that's the short run cost function, and in our construction, I hope you will appreciate the process we use to construct this cost function. And again, a key feature here is that in the short run, if we produce nothing, the associated cost is not equal to 0 anymore.